Hello students, I myself Professor M. N. Zado from Kekewak Polytechnic Nasik. Today we are going to learn the basic introductions about oscillators. So now we'll see one by one. What is oscillator? Oscillator, it generates a waveform without any input AC signal. This is an electronic circuit that converts the DC energy into AC energy at a very high frequency. An amplifier with a positive feedback can also be called as an oscillators. Now we see that what is the basic comparison between oscillators and amplifier. An amplifier increases the strength of the input signal which is applied for it, whereas the oscillator generates a signal without any input signal. But oscillator requires the DC for its operations. This is the major and the main difference between amplifier and oscillators. From the block diagram, you can observe there is no input signal for oscillator, whereas there is an input signal for an amplifiers. One more thing is that an oscillator is having positive feedback. What are the classifications of oscillators? Basically, oscillators are classified in two categories. Number one, as a sinusoidal oscillators. The oscillator that produces an output having a sine waveform is called sinusoidal oscillator, or the other name is also called as harmonic oscillators. These oscillators can provide the output at frequencies which are ranging from 20 Hz to 1 GHz. And second type for the oscillators are called as non-sinusoidal oscillators. These oscillators can produce an output which having the square wave, rectangular wave, or sawtooth waveform in the form of the output signal. Such oscillators can provide the output at frequencies which are ranging from 0 Hz to 20 MHz. Here, there are the sub-classifications of sinusoidal oscillators. The sinusoidal oscillators can be classified as tuned circuit oscillators, RC oscillators, crystal oscillators, and negative resistance oscillators. Now we'll see in short what is tuned circuit oscillators. These oscillators are used the tuned circuit components which are inductor and capacitors, and they are used to generate the high frequency signals. They are also known as radio frequency oscillators, and they are further classified as Hartley oscillator, Colpitt's oscillators, and Clap oscillators. The second type of sinusoidal oscillator is RC oscillator. This oscillator uses resistors and capacitors as the basic components, and basically they are used to generate low frequency signals. And because of that, they are also called as audio frequency oscillators. Such oscillators are subclassified as RC phase shift oscillators and Van bridge oscillators. The third type of sinusoidal oscillator is crystal oscillators. In this oscillator, a quartz crystal is used to generate the frequency which having the range up to 10 MHz. The piezo oscillators is an example of a crystal oscillators. And the fourth type of sinusoidal is negative resistance oscillators. This oscillators uses the negative resistance characteristics of the devices such as tunnel devices. A tuned diode oscillator is an example of a negative resistance oscillators. Now here we'll see the nature of sinusoidal oscillators. Basically, there are two types: damped oscillations and damped oscillations. Now, what is damped oscillations? In which your frequency or the amplitude of the oscillator goes on decreasing. It's called as the damped oscillations. The damped oscillations are generally produced by the oscillator circuit that produces power losses and doesn't compensate if required. The second we'll call as undamped oscillations, in which the amplitude remains constant with the time signal. The undamped oscillations are generally produced by the oscillatory circuits, and that can produce no loss, no power loss, and follow the compensation techniques if any power losses occurs. Now, what is a practical oscillator circuits? Here the diagram indicates for the same. It consists of three basic parts, which are tank circuit, second is transistor amplifier, and third one is feedback circuits, each having some particular functions. In a tank circuits, we are basically using the components L, that is inductor and capacitors. The values of these two components determine the frequency of the oscillator circuits. The second, transistor amplifier. In this, the output of the tank circuit is connected to these amplifier circuits so that the oscillations produced by the tank circuits are amplified, and hence the output of the oscillations are going to increase. The third part of oscillator circuit is feedback circuit. The function of feedback circuit is to transfer a part of the output energy to LC circuit in proper phase. This feedback is positive in oscillators, while the feedback is negative in amplifier circuits. Now, the frequency of oscillators are going to depend on the various parameters which are listed as the operating points of the active device, that is transistor. Second is circuit components. Third parameter is supply voltage, and the last parameter, that is the output voltage used in the circuits. Thank you.